Welcome. In this video, we are going to discuss the attributes of sensation. So by the end of the video, you should be able to describe the concepts of absolute threshold and difference threshold, as well as discuss the roles that attention, motivation, and sensory adaptation play in perception. So the first attribute of sensation we are going to talk about is the intensity of the sensation. Now, the strength of the sensation results in the intensity of the sensation. And this is going to be based on the number of axons that are stimulated and the frequency of action potentials. So the intensity of the stimulus is going to help us distinguish stimuli that are stronger or weaker from one another. So the more axons stimulated, the stronger the intensity of the sensation. The more frequent the action potentials, the more intense the sensation is. So here is an image of the eye. And we're seeing here light waves hitting the retina, synapsing on photoreceptor cells, synapsing on a couple of other cells before they send a signal along the optic nerve. And so the optic nerve is a bundle of myelinated axons. So again, the number of axons that are stimulated in this optic nerve, as well as the frequency, how fast those action potentials travel along the optic nerve, is going to tell the brain how strong that sensation is, how intense that sensation is. This leads us to the concept of absolute threshold. An absolute threshold is the smallest amount of energy that can be reliably detected 50% of the time. Now, this is variable, and it can be influenced by practice, fatigue, context. So what is the smallest number of axons that need to be stimulated for us to see something, or to smell something, or to hear something? One example of absolute threshold for vision is a single candle flame 30 miles away on a clear night. For sound, the tick of a watch from 20 feet in total quiet. Or for taste, a teaspoon of sugar and a gallon of water. So that is the amount of stimulation at the sense organ that can be reliably detected 50% of the time. So again, if you knew that sugar was going to be in the water, the context, you might be able to taste it sooner. Or if you were really tired, you might not be able to hear the tick of a watch from 20 feet away in total quiet, because all of these things, practice, fatigue, context, can influence the absolute threshold. Another important concept is difference threshold. So difference threshold is the smallest difference that can be detected when two stimuli are compared. Again, this is variable. So the researchers determine this when the difference is detected 50% of the time. It's also sometimes called the just noticeable difference. So when comparing A to B, the ability to notice this difference depends on the intensity of A. So you might be able to tell the difference in 1 teaspoon of sugar in coffee and 1.5 teaspoons, but maybe not a tablespoon or a tablespoon plus a half a teaspoon, because again, the intensity of 1 tablespoon is much more than 1 teaspoon. And so you would need a bigger difference to distinguish the two. Or perhaps the weight of 2 objects. Which apple is heavier? The next attribute of sensation that we're going to discuss is duration. And this is the relationship between the stimulus intensity and the perceived intensity. So think about it. If a stimulus persists for a long time, our perceived intensity of it diminishes. And this is called sensory adaptation. So it's the reduction or disappearance of sensory responsiveness when a stimulus is unchanging or repetitive. So think about an ice pack. You sprained your ankle or you bumped your head and you put some ice on there. And at first it's almost intolerable. You can't stand the cold. But after a few minutes, it's fine. The temperature of the ice hasn't gone down. Maybe if you left it on there for an hour or so, it would. But the stimulus is the same. It's unchanging and we're not responding to it. So this prevents us from having to respond continuously to unimportant information. Another example, how many of you wear a watch or a ring or eyeglasses? Now that pressure on your skin from those different items is continuously there, but we're not attending to it all day. And this is because of that sensory adaptation. It would be silly for us to constantly have our brains responding to this stimulus because it's unimportant information. Now, of course, like sometimes when I go walking, my fingers might swell a little bit and then I'll feel that ring. Or maybe you snag your watch on something and you feel it. But that's changing pressure, right? That the pressure has changed, it's not unchanging. Another important concept is sensory deprivation. Now, early studies on sensory deprivation found that subjects became very edgy when they were deprived of sensory information. And so sensory deprivation is the absence of normal levels of sensory stimulation. But part of it was the perception of the sensory deprivation. So there was a negative connotation, and so people got disoriented, some even had hallucinations. But now we know if you're in the right frame of mind, sensory deprivation can be quite relaxing. Some people, spend a lot of money to go to spas and have sensory deprivation. So it can heighten your awareness of your senses, but it is important to understand that the brain does need a certain amount of minimum stimulation to function normally. And in case you're having a little difficulty trying to understand what sensory deprivation is, if you've seen Stranger Things, Elle goes in a sensory deprivation tank to try to connect with others. Now that's a little paranormal, but the idea is that it's heightening her senses. The movie Daredevil, it's like kind of a bad superhero movie with Ben Affleck. He is blind, I believe, and so he goes into a sensory deprivation tank at night to sleep, and it heightens his other senses. On the other hand, too much stimulation can be bad. Babies often get fussy when there's overstimulation. Think about when you're on a date in a crowded restaurant. Do you hear the conversations that are happening at the table next to you? Or do you hear the waiter taking everyone's order? Hopefully not. Hopefully you have what's called selective attention. Now, my husband has a hard time with this. He has to focus really hard on listening to what people at the table are saying and not getting distracted by those sounds around him. So selective attention is the ability to focus on some parts of the environment and block out others. There's also something called inattentional blindness, and this is when you're not seeing something that you're looking directly at. Maybe you're looking for your keys and they're right in front of you. So the stimulus is there, but we're not perceiving it. So let's give an example of how this could really have an effect in real life. Let's think about what we've learned now about inattentional blindness, not seeing something that's right in front of you, maybe because you're distracted by doing something else, or the idea of selective attention when you're focusing in on one thing and blocking everything out. Now, does it seem like texting and driving would be a good idea if your attention's not focused on what's on the road in front of you? Maybe one of these things, selective attention or intentional blindness, could lead to an accident.